name is Karuna Singh. Welcome to the channel North Star Continuous Knowledge Excellence. In this video, we will get to know about the detection of heavy metal, lead and cadmium. Now, our expert, Professor Himadri Bohidar, who is associated with National Center Excellence in Agro Nanotechnology, Terry Tycan Nanotechnology Center, India. He has 31 years of academic experience in teaching and research. His area of expertise includes nanoscience and nanotechnology, nanobiointerface science, soft matter science, polymer physics, biophysics. Will explain you in detail about this topic. So, to get complete information, watch full video without skip.
Detection of heavy metals. So we have two heavy metals in our target here, the cadmium 2 and PP2. It's by mistake written cadmium 3 here, should be CD2. Okay, so here we are going to use yet another strategy. So I'm giving you specific 4 different examples here where electrochemistry is being used, but different strategy is being used. No two strategies are same. First, we saw electrochemical IV characteristic. Second one, impedance. This is from ratiometric differentiation. How do we detect heavy metals, or how do you make a sensor? This is the third examples of it. So what we'll do is, again, we'll make a electrode, nanomaterial based electrode, and we're going to use a ratiometric signal. Like there is a reference signal and there is the signal that is coming from the sample. We'll take a ratio of that and make that as an indicator to detect heavy metals. That is the whole idea. It can be else again done with very simple strategy. Let's see the details. This is the pictorial view of what we are going to do. We have a substrate which has got predominantly copper ions on it. Okay, Cu2 plus. Okay, I can do a cation exchange with lead 2 or cadmium 2. If I do a lead 2, some of the copper will be replaced by lead here, red dots here, and the copper ion sitting here. Similarly, if I do an ion exchange with cadmium, then the green balls representing cadmium will come here and rest copper will stay bulbs here.
Wait. Are you worried about your project, training, dissertation, internship? Don't think too much, because Nanoscience and Technology Consortium, in short NSTC, is giving you a golden opportunity to do the same tasks. NSTC also conducts workshop on amazing topics. So if you want to register in the workshop, the registration link is given in the description box below, or you may go to the website www.nanoschool.in, where you can easily enroll in the workshops. So just check it out right now.
I'll do a cyclic voltammetry again and look at the current voltage response. You see here that there is a response signal corresponding to lead. There is also a response signal corresponding to the copper. So there is a substrate signal and there is a sample signal. With the increase in the concentration of the lead in this ion exchange reaction, this signal strength will increase, this signal strength will decrease. Story is the same if I replace lead with cadmium. Same 2 peaks will be there. One signal will go up, other signal will come down because the quantity of copper is going down. So it will go down because copper is replaced by cadmium. Same story here. Lead is replacing copper. So copper goes down, lead goes up. So if you take the ratio between these two, concentration of PV divided by concentration of Cu, or concentration of CD divided by the concentration of Cu, then you have a ratio which is the indicator of the concentration of the analyte in your sample. That is going to be used at the indicative parameter. Okay, as usual, first synthesize the electrode. So if the starting material is benzene tricarboxylic acid, is dissolved in ethanol, then this copper acetate hydrate is and classic glacial acetic acid are dissolved in water again under ultrasonic radiation. Now they add the copper acetate solution to the previous solution here and mix them well under constant stirring and leave it for an hour or so at room temperature conditions. Then you will see white precipitates will develop there. Bluish white precipitates will be formed, lightly bluish. And then you dry the products, aliquots, at around 80 degree for about 12 hours in a standard oven. Then you have your copper nanoparticles available ready for you. Okay, so this is the synthesized product that we have seen. Just we have made the TM picture of that and the XRD picture of this one. This is the synthesized product because so many peaks are there in the XRD products. It's a very highly crystalline material. Okay, now when you expose it to other elements like cadmium, copper, and other things, this change, but this change is very, very subtle. It's very difficult to distinguish here, but electrochemically you will be able to see it much more clearly later. That's the whole idea. So this is the bare electrode. This is after exposure to the lead or cadmium pollutants.
I hope you liked the video. Here I would like to give you an important information that Nanoscience and Technology Consortium or NSTC organize the nanotechnology workshops on amazing topics. Also, I would like to tell you about the initiatives of NSTC in which you can also be a part of. Mentorship, patent commercialization, joint product development, research projects, consultancy services, nanomaterials for your research projects, training programs or customized training programs, workshops or customized workshops. One more thing, and that is, if you want the full recording of the previous videos, so you can contact us on info@nstc.in. Further, if you want to enroll in the upcoming workshops, then you can go to the website www.nanoschool.in. And yes, subscribe to the channel Knowledge Star and hit the bell icon to never ever miss an update. Thank you.
For more updates, subscribe to our channel, click the links shown on the screen to stay connected.